Alright, this is a quick video on the area of parallelograms. Now we're going to refresh real quick and go back and review a little bit the different types of parallelograms we could have. And there are four special types of parallelograms. First one is the actual parallelogram. Second one, we could have a square. Third, we could have a rectangle. And finally, we could have a rhombus. Now, of these four shapes, for the area formula that we're going to be talking about, what's nice is that the top three, the parallelogram, the square, and the rectangle, all have the same formula for the area. The rhombus is a little different, and we'll get to that a little later. But the top three, the parallelogram, the square, and the rectangle, they all have the same formula. And most of you are going to know this when you hear it. The formula for the area of a parallelogram is base times height, b times h. Now, we're going to go through the different shapes. For a square, we know that all the sides are the same. And the base would be what it's sitting on, and the height would be how tall it is. So here's our base and our height, and we would just multiply those two things together. Now, one thing that we need to remember is when we're talking about area, our label is always units squared, so inches squared, feet squared, whatever we're talking about squared. And we do that because we're multiplying two things together to find the amount of space that it would take up. So it's in two dimensions, length and width. So the length would be like our base or our height, and then the width would be the other one. Depends on how you look at the figure. But that's for a square. All the sides would be the same. Now, one thing about a square is that the base and the height would be the same number. Since all the sides are the same, they have to be the same value for a square. So that's just a little extra tidbit, something to think about. For a rectangle, our height and our base would be about the same. They'd just be different numbers, unlike the square. One would be bigger than the other. And we'd multiply them together, and we'd get units squared for our answer. The parallelogram is the one that's a little different, and this is the one that people would think would actually have a different formula, but it really doesn't. What we would do is we would cut the triangle part off the end here, and we're going to call that the height. And then our base is going to be this whole bottom part, everything across the bottom. Okay, now I'm going to redraw this and show you what actually happens. If we were to cut that triangle off, what's going to happen is that it's actually going to fit in the end over here. So this would be gone, and then we end up with a rectangle, which would be base times height. So that's why a parallelogram ends up having the same formula as a square and a rectangle, because we could cut that triangle on the end off and just shift it around to the end. Okay, we've got two examples. We're going to work through them really quick, because I don't think this is too difficult for most of you. Okay, the examples just say to determine the area. For a shape, we have a rectangle, and we're just going to multiply the base times the height. So 4 times 12 would be 48, and we have meters as our label, and we want meters squared. So that would be the answer to our problem. Second one over here is a parallelogram, and we have our height of 3 and our base of 7. So we'd multiply 3 times 7, which is 21, and we put a feet, because that's our label for the problem, and we square it, feet squared. And then we'd be finished. So for the area, I know most of you know this already, but I just want to reiterate that a square, a rectangle, and a parallelogram, they all have the same formula because they're all special types of parallelograms, and that's base times height.